2005 NEC 410.73G addresses the installation of temporary wiring specifically in generator installations. The purpose of this requirement is to ensure a safe and practical approach to setting up temporary electrical connections when using generators. It's crucial to understand that this section is not intended as a comprehensive design manual, but rather as a set of minimum safety standards that must be followed. The core of 410.73G lies in its stipulation that temporary wiring is only permitted to supply essential equipment. Essential equipment refers to devices and systems that are absolutely necessary for the operation of the generator itself and for maintaining a minimal level of functionality during a power outage or other temporary power situation. Examples of essential equipment typically include lighting, providing sufficient illumination for safety in operation, ventilation, ensuring adequate air circulation to prevent overheating of equipment and to maintain air quality, and communications, allowing for necessary communication between personnel or with external services. It is paramount to limit the use of temporary wiring to these essential loads to prevent overloading the system and to minimize the risk of hazards. Furthermore, 410.73G emphasizes the importance of installing temporary wiring in a manner that minimizes the risk of damage or entrapment. This means that the wiring must be routed and secured in such a way that it does not create a tripping hazard for personnel working in the area. Exposed wires lying on the floor or strung across walkways are unacceptable. Proper securing methods, such as using cable ties, straps, or other appropriate fasteners, should be employed to keep the wiring organized and out of the way. Additionally, the wiring should be protected from potential damage from equipment or other objects that may be present in the area. This could involve using conduit, cable trays, or other protective measures to shield the wiring from physical impacts or abrasion. Entrapment refers to situations where individuals could become entangled in the wiring, potentially leading to injury. This can be avoided by ensuring that the wiring is properly supported and routed in a way that prevents it from becoming a hazard. While 410.73G provides a minimum level of safety for temporary wiring in generator installations, it is important to recognize that it is not a substitute for a comprehensive electrical design. A complete design would take into account a wide range of factors, such as the specific loads to be served, the available power from the generator, the characteristics of the wiring, and the environmental conditions. However, 410.73G can serve as a valuable starting point for the design of temporary wiring systems. By adhering to the requirements outlined in the section, you can ensure that the wiring is installed in a safe and practical manner, minimizing the risk of hazards and ensuring the reliable operation of the generator. In practical terms, complying with 410.73G involves several key steps. Firstly, carefully assess the essential equipment that needs to be powered by the temporary wiring. This assessment should be based on the specific requirements of the generator installation and the needs of the facility or equipment being served. Secondly, select appropriate wiring and overcurrent protection devices that are properly sized for the loads being served. The wiring must be capable of carrying the anticipated current without overheating, and the overcurrent protection devices must be rated to protect the wiring from overloads and short circuits. Thirdly, install the wiring in a manner that minimizes the risk of damage or entrapment, as described above. Fourthly, thoroughly inspect the completed installation to ensure that it meets all of the requirements of 410.73G and other applicable codes and standards. The inspection should include a visual examination of the wiring, connections, and overcurrent protection devices, as well as electrical testing to verify the integrity of the system. Finally, it is important to remember that temporary wiring is intended to be just that, temporary. As soon as the permanent power source is restored or the generator is no longer needed, the temporary wiring should be removed and the electrical system returned to its normal configuration. Leaving temporary wiring in place for extended periods can create hazards and increase the risk of accidents. Let's delve deeper into specific aspects of the NEC section 410.73G to provide a more comprehensive understanding. When assessing essential equipment, it is not just about what is necessary, but also about what is not. Avoid the temptation to connect non-essential loads to the temporary wiring system. This helps to prevent overloading and ensures that the generator's capacity is focused on critical functions. Consider using a load management system or a clearly labeled distribution panel to help control which loads are connected to the temporary wiring. For selecting the right wiring, consider the ampacity of the conductors. This is the maximum amount of current, measured in amps, that a conductor can safely carry without exceeding its temperature rating. Consult NEC Table 310.15b16 for ampacity values based on conductor size, insulation type, and ambient temperature. Remember to apply any necessary correction factors for ambient temperature or the number of conductors in a raceway or cable. Also, ground all non-current carrying metal parts of the temporary wiring system. This includes enclosures, raceways, and equipment frames. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Use appropriately sized grounding conductors and ensure that all connections are tight and secure. In addition to minimizing physical damage, protect the temporary wiring from environmental factors such as moisture, chemicals, or extreme temperatures. Use wiring and connectors that are rated for the specific environmental conditions present at the installation. If the wiring is exposed to moisture, use waterproof connectors and seal any openings to prevent water from entering the system. When inspecting the temporary wiring insulation, look for any signs of damage or wear. Check the insulation for cuts, abrasions, or cracks. Verify that all connections are tight and secure. Test the overcurrent protection devices to ensure that they are functioning properly. Use a multimeter to measure voltage and current to verify that the system is operating within its rated limits. Document the temporary wiring installation. Keep a record of the equipment that is connected to the system, the size and type of wiring used, the ratings of the overcurrent protection devices, and the results of any inspections or tests. This documentation can be helpful for troubleshooting and for future reference. It's worth reiterating that temporary wiring should be removed as soon as it is no longer needed. When removing the wiring, de-energize the circuit and carefully disconnect all components. Inspect the wiring for any signs of damage and dispose of it properly. Do not leave temporary wiring in place indefinitely, as this can create a safety hazard and violate electrical codes. Furthermore, ensure that the generator is properly maintained and operated according to the manufacturer's instructions. This includes regularly checking the oil level, coolant level, and fuel level. Keep the generator clean and free of debris. Do not overload the generator, as this can damage the engine and electrical components. By following these guidelines, you can help ensure the safe and reliable operation of temporary wiring in generator installations. Remember that electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. The NEC 410.73G provides a solid foundation for safe temporary wiring in generator setups. However, remember that it is a minimum standard, and a comprehensive design is always recommended for optimal safety and efficiency. Consider all factors, from load assessment to environmental protection, and prioritize regular inspection and documentation. Proper grounding, conductor selection, and overcurrent protection are also crucial elements. If unsure, always consult a qualified electrician to ensure a safe and compliant installation. Consider the impact of ambient temperature on conductor ampacity. High ambient temperatures can reduce the ampacity of conductors, meaning they can carry less current safely. NEC Table 310.15b16 provides ampacity values for conductors at a specific ambient temperature, typically 30 degrees Celsius or 86 degrees Fahrenheit. If the actual ambient temperature is higher than this, you must apply a correction factor to reduce the ampacity of the conductors. The correction factors are provided in NEC Table 310.15b2. For example, if the ambient temperature is 40 degrees Celsius and the conductor has an insulation type with a temperature rating of 75 degrees Celsius, the correction factor would be 0.91. This means that the ampacity of the conductor must be reduced by 9%. Similarly, consider the number of current-carrying conductors in a raceway or cable. When multiple current-carrying conductors are installed in the same raceway or cable, the heat generated by each conductor can raise the temperature of the other conductors. This can reduce the ampacity of the conductors. NEC Table 310.15b3 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. For example, if there are 4 to 6 current-carrying conductors in a raceway or cable, the adjustment factor would be 0.80. This means that the ampacity of each conductor must be reduced by 20%. When using flexible cords for temporary wiring, ensure that they are listed for the intended use and that they are properly protected from damage. Flexible cords are more susceptible to damage than permanently installed wiring, so it is important to take extra precautions to protect them. Use cord protectors to prevent the cords from being crushed or cut. Avoid running cords across walkways or doorways where they could be tripped over. Do not use cords that are frayed or damaged. Choose the right type of flexible cord for the application. For example, use a heavy-duty cord for powering tools or equipment that draw a lot of current. Use a cord that is rated for outdoor use if the wiring will be exposed to the elements. Proper grounding is crucial for safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. This helps to prevent electrical shock and fire hazards. Ground all non-current carrying metal parts of the temporary wiring system, such as enclosures, raceways, and equipment frames. Use appropriately sized grounding conductors and ensure that all connections are tight and secure. Test the grounding system to verify that it is functioning properly. Use a ground resistance meter to measure the resistance of the grounding electrode system. The resistance should be low enough to allow sufficient fault current to flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring from overloads and short circuits. These devices trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing damage to the wiring. Choose overcurrent protection devices that are properly sized for the wiring and the loads being served. The overcurrent protection device should have an ampacity rating that is no greater than the ampacity of the wiring. Coordinate the overcurrent protection devices to ensure that the device closest to the fault trips first. This helps to minimize the extent of the outage. Test the overcurrent protection devices regularly to ensure that they are functioning properly. Use a circuit breaker tester or a fuse puller to test the devices. Remember that the NEC is constantly evolving to address new technologies and safety concerns. It is important to stay up to date on the latest code requirements to ensure that your electrical installations are safe and compliant. Attend training courses, read industry publications, and consult with qualified electricians to stay informed. And always consult the authority having jurisdiction, or OJ, for clarification on local codes and interpretations. Temporary wiring, while useful, always presents elevated risks compared to permanent installations. Regular inspections are paramount. Check for wear and tear on cords, loose connections, and any signs of overheating. Immediate repairs are crucial. Never ignore damaged wiring or faulty connections. Replace them immediately. Always disconnect power before performing any repairs or modifications. Establish clear safety protocols for anyone working with or around temporary wiring. Training on safe practices and hazard awareness is essential. Consider the use of ground fault circuit interrupters or GFCIs for temporary wiring systems, especially in damp or wet locations. GFCIs can detect even small amounts of leakage current and quickly de-energize the circuit, reducing the risk of electrical shock. Clearly label all temporary wiring and equipment to avoid confusion and prevent accidental contact. Use tags, signs, or other markers to identify the purpose of the wiring and the equipment it serves. Keep temporary wiring away from flammable materials and sources of ignition. Ensure that the area around the wiring is clear of combustible debris and that there is adequate ventilation. Never overload temporary wiring circuits. Use a circuit tester to verify that the load is within the capacity of the wiring and the overcurrent protection device. Avoid using extension cords daisy-chained together. This can create a fire hazard and overload the circuit. Instead, use a single extension cord of the appropriate length and gauge. Always prioritize safety when working with electricity. If you are not comfortable working with electrical wiring, consult a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. With all the above points considered, remember that temporary wiring is exactly that, temporary, and so permanent solutions should be implemented as soon as possible.